Hello everyone, welcome to numerical problem of electrical machine. And today our numerical problem is a 4-pole generator with wave wound armature has 51 slots, each having 24 conductor. The flux per pole is 10 milliweber. At what speed must the armature rotate to given an induced EMF of 0.24 kilovolt? What will be the voltage developed if the winding is lap connected and the armature rotates at the same speed? First of all, given number of pole 4 and A equal to 2 because this is wave winding. Z equal to, this is 51 slots into 24 conductors, so 1224, and phi equal to 10 milliweber, so 10 into 10 power minus 3 weber, and we have to find the value of N, that is the speed, and EZ equal to 24 0.24 kilovolt, so 0.24 into 10 to the power 3 kilovolt, and we know E is equal to 5 ZNP, that is upon 60 A. So from here we can get the value of N equal to 60 A into Eg upon 5 PZ. Then put the value of A, Eg, 5 PZ, then you can get the value of N. The value of N is 588.23 RPM. And again A equal to P equal to 4. This is for lap winding. Eg2 equal to 5Z N 5ZP upon 60. So put the value of N 5Z and A. We can get 119.54. To find the voltage developed, we use lap winding. What will be the voltage developed if the winding is lap? So at this condition we have to find the voltage, and A equal to P equal to 4 for lap winding, A equal to P, number of pole equal to A. Okay, and the next problem is a 250 volt DC shunt motor has armature resistance of 0.25 ohm. On load, it takes an armature current of 50 ampere and runs at 750 RPM. If the flux of the motor is reduced by 10% without changing load torque, find the new speed of the motor. VL equal to 250, this is VL. RA 0.25, IA 50, N1 equal to 750 RPM. To find N2 when phi is reduced by 10% and torque is same, then EB equal to VL IA RA. So VL already given 250 minus 0.25 into 50, 237.5 ampere, and we know EB equal to N1 N phi. So EB1 equal to N1 phi is reduced by 10%. Okay, then phi equal to EB1 upon N1, that is 237.5 upon 750, so 0.316 Weber, and 10% of phi t, total phi is reduced by 10%, so new phi equal to phi t minus 0.0316. So 0.316 minus 0.0316 is 0.285 Weber, and EB equal to phi nu into N2, so N2 equal to EB upon phi nu, that is 237.5 upon 0.285 is 833.33 RPM. And next problem is a 10 horsepower 230 volt DC shunt motor takes an armature current of 6 ampere from the supply at no load and runs at 1200 RPM. The armature resistance is 0.20 ohms. Determine the speed and electromagnetic torques with 37 ampere armature current and same flux. This is the circuit diagram of above problem. Here Vt equal to 230, I equal to 6 ampere, N1 equal to 1200 RPM, Ra equal to 0.20 ohm. This is 0.20 ohm. We have to find N2 and armature torque. Ia equal to 37 ampere and phi is same. So EB equal to VT minus IARA, that is 230 minus 6 into 0.20, that is 228.8 volt, and EB2 equal to 230 minus 37 into 0.20, so EB2 equal to 222.6 volt, and we know EB direct EB equal to N151, so phi 1 equal to 22 point 1200 0.1906 Weber, and EB1 equal to N1 phi, EB2 equal to N2 phi, so EB1 upon EB2 equal to N1 phi 1, then we can get the value of N2, and the value of N2 is 1167.48 rpm. And we have also find the value of torque. The value of torque is, we know the formula for torque is phi z p ia upon 2 pi a. Put the value of phi z p ia and value of a, then we can get the torque. And again, next problem. Next problem is a 440 compound DC generator has an armature series field and shunt field resistance of 0.05 ohm and 1.0 and 200 ohm respectively. Calculate the generated voltage when deliver 40 ampere to external circuit for both long shunt and short shunt connection. From the question, VL equal to 440 and RES equal to 0. RA equal to 0.05, RES equal to 1.1 ohm, and RESH equal to 200 ohm, IL equal to 40 ampere. First case, long shunt compound generator. This is the diagram. This is shunt, so RES is in parallel. Then ISH equal to BSH upon RESH. So 440 upon 200 is 2.2, and EG equal to BL plus IARA plus ISC RESC. Then put the value of BL, IARA, ISC, RESC. Then you can get 484.31 volt. And next case second, when the machine is shunt compound DC generator, then the figure is like this. Then EG equal to BL plus ISC RA IA, but ISC equal to IL equal to 40 ampere, and IA equal to ISH plus ISE. VL equal to VT equal to V1 plus this V1 plus V2. So V1 equal to ISE into RESC, that is 40 volt, and V2 is equal to VL minus V1, that is 400 volt, and ISH equal to V2 upon RSH. So 400 upon 200 is 2 ampere in IA. Then the value of IA equal to ISH plus ISE. Then we can get 42, and EB equal to BL plus IRSE into ISE plus RA IA. Then we can get 482.1 volt. And the next problem is a 230 volt of DC shunt motor takes an armature current of 3.33 ampere at no load speed of 1000 rpm. The armature and the field resistance are 0.3 and 160 ohm respectively. The line current is 100 ampere. Calculate the speed and the developed torque in case when the armature reaction weaken at the flux by 4%. This is the circuit diagram of the above problem. And here given VL equal to 230, IA equal to 3.3, NN equal to 1000 RPM, RA equal to 0.3, RS is equal to 160, IL equal to 100 ampere. Now to find N2 and torque. When flux is weakened by 4%. First of all, EB1 equal to BL minus IARA. Put all the value of BL, IARA, we can get the value of E1. Then after getting the value of E1, E1 equal to N1 phi1. So phi1 equal to EB1 upon N1. Then we can get 0.229 Weber. In case second is flux is reduced by 4%. So phi2 equal to 4% of this flux, that is 0.229 minus 4% of 0.229, so 0.219 Weber. And also IL equal to 100 ampere already given in the question. So EB2 equal to IL minus IARA, IA equal to IL minus ISCS. IS is equal to BSS upon RSS. So BS is already given 230 upon 160, that is 1.437 ampere, and IA equal to 100 minus 1.437 is 98.563 ampere. Therefore EB2 equal to BT minus IARA. Then put all these value, you can get the value of EBT 200.431 volt. Now EB1 upon EB2 equal to phi1, N1 phi1 upon N2 phi2. So from here we can get the value of N2. N2 equal to EB2 into N1 phi1 upon EB1 into phi2. Then put all these value, we can get the value of speed. And again the value of torque. Torque equal to phi z p ia upon 2 pi a, and then EB upon 2 pi 60 by n into ia. This is the value of EB, and this value is EB except phi, and divide by 60 by n, that is into ia. And put all these value, you can get the value of torque. Value of torque is 2 to 6.69 Newton meter.